Hello again. This video is about Unit 2, Standard 2, which is limits and infinity. So we're going to look at two types of things. What happens when you find a limit and you get infinity, and also what happens if you find a limit at x goes to infinity. So basically, this whole standard has to do with infinity. Here's what I want you to read. We'll read it together. When evaluating a limit, if direct substitution yields a number over 0, that means you have a vertical asymptote. Or that means if you have a number over 0, that means your limit goes to infinity. So every time you have a number over 0, it goes to infinity. Okay? That means C plus or C minus, as a number goes to plus or number to minus, have to equal either positive infinity or negative infinity. Now we're going to skip over this example. It doesn't have to do with what we need to know for calculus. But let's look what I mean by solving for infinity. So this is what the steps are. First of all, you're going to plug in the number, like we usually do for limits, and determine if the numerator, again, just the numerator, is it positive or negative. Okay. Then, if you happen to get a number over 0, you're going to keep your numerator and try to figure out what the sign is of the denominator. Okay. If you get a C plus, put in a number slightly greater to determine the sign of the denominator. If you get a C minus, substitute a number slightly less than C, and again, just to see what the sign is. If your numerator is plus over, if your fraction is plus over plus or minus over minus, you get positive infinity. If you get plus over minus or negative over positive, you get negative infinity, because positive divided by negative is negative. Okay, it might be a very complicated process, but again, I'm going to go through an example so it makes sense for y'all. Let's look at this first one. This first one says limit as x goes to 2. So I'm going to plug this in. 2 minus 3 is negative 1. If I plug in 2 into the denominator, I get 4 minus 8 plus 4, which gives me negative 1 over 0. This is not like 0 over 0, where I could simplify it or whatever. If I get a number over 0, that tells me that the answer is some sort of infinity. Okay. Now, what do I do when I find something with a number over 0? I'm going to, because this problem is just a 2 by itself, I need to, again, see this problem from the left and from the right. So I'm going to write down 2 columns, left and right. Okay. Now, you already know, because we solved it, we plugged in 2, my numerator at 2 is negative. So my numerator for sure is negative from the left and the right. All I have to try to figure out is what is the sign of the denominator. Now, because the limit as x goes to 2, again the problem is 2, a good number to test from the left, okay, think for yourself, what's a good number to test from the left of 2? The answer is 1. Okay, so I'll plug in 1 into the denominator only to figure out what the sign is. If I plug in 1, I get 1 minus 4 plus 4. 1 minus 4 plus 4. I get 1. 1 is a positive number. So from the left, I get negative over positive, which means from the left, I have a limit that goes towards negative infinity. Okay. Remember, the answer has to be infinity. All I'm doing is checking the signs. From the right, I need to plug in a number that's slightly more than 2. The best number to test would be 3. So let's plug in 3. I get 9 minus 12 plus 4. 9 minus 12 plus 4 is 13 minus 12, which gives me a positive 1. That means the denominator is positive. So negative divided by positive is a negative infinity. Because the limit from the left is negative infinity, the limit from the right is negative infinity, that means the answer is negative infinity. Okay, not a very difficult process. It's probably a little bit easier than the 0 over 0s we were doing earlier. Let's try this one that says as x goes to 4. I'll plug in 4, again to simplify or to speed this up. 4 squared is 16. 16 plus 4 is 20. 20 minus 5 is 15. Plug in 4 on the bottom, I get 16 minus 16, which is 0. I get a number over 0, which means my answer has to be some sort of infinity. I don't know what kind of infinity, I just know that the answer is infinity. So that's why, oh, sorry for my reminder. That means I need to test from the left and the right to see what's the sign of the infinity. So again, I'll make two columns, left and right. When I do the left, I'm going to test a number to the left of 4. In this particular problem, I had 15 in the numerator, which means the sign for both sides is already positive in the numerator. For the denominator, I'll test the number to the left. Let's try 3. 3 squared is 9 minus 16, which is a negative number. I don't have to solve it, I just need to know what the sign is. Positive or negative. From the left, the limit is negative infinity. Let's try it from the right. I'll try 5. 5 squared is 25 minus 16. Again, I don't need to solve it. I already know the answer is going to be positive. In this case, I get positive over positive, or my limit is positive infinity. Now, as I told you, you have to check if they match. In this particular case, they don't match, which means the answer is D and E. Okay? And then just one example for you all. If you go to the next page, let's look at this problem right here where it says x goes to negative 3 plus. When I see a problem and it only has one sign, negative 3 plus, that means I only have to check from one side. Okay? So in the past, I did column left and column right. In this particular problem, I only have to do one column. In this case, the problem is right. In the next one, we're not going to do it. I have negative 2 minus. I only have to do the left side. So it makes your process a little bit easier. So again, let's make this really quick. In this case, I'll plug in negative 3. On the top, negative 3 squared is 9. 2 minus 9 is negative 7. On the bottom, plug in negative 3. I get 9 minus 15 plus 6, which is 0. Negative 7 over 0. Means the answer is infinity. What kind of infinity? Well, we have to find the sign. This is negative 3 plus, so I'm only going to write right. Okay? A number that's to the right of negative 3 is negative 2. So I'm going to plug in negative 2. Again, my numerator I already know is negative. My numerator is already negative. I solved it up here. I just need to find the sign of the denominator. So let's try it. On the right is negative 2. Negative 2 squared is 4. Minus 10 plus 6. I get a 0 again. No good. And you're probably saying, what did I do wrong? That means you actually found another infinity limit. But in this particular case, that's no good. What I need to do is find another number to the left of negative 3 that does not give me 0. So let's try negative 2.5. Okay, you can use a calculator. Negative 2.5 squared is 6.25. Okay, negative 2.5 times 5 is, let me calculate real quick. Negative 2.5 times 5 is negative 12.5. And then plus 6. So in this particular case, I don't need to do the math, but if I add like so, I know I'm going to get a negative number in the denominator. Oh, so you can't see that. I know I'm going to get a negative sign. Oops. I'm going to get a negative sign in the denominator because I have 12.25 minus 12.5. That gives me negative. Numerator is negative. Denominator is negative, which means my answer is positive infinity. Now, if you have a problem that has a sign, like this one is negative 3 plus, or the one next to it is negative 2 minus, if you have a sign, there has to be an answer. The answer cannot be does not exist because there's no left and right. There's only left and there's only right. So you better have an answer. The answer cannot be D and E. And that's how you solve problems where you get a number over 0 and the answer is infinity. Now, we're going to skip over a few pages in your packets. We did that one already. Skip over the one that says horizontal asymptotes. In this particular case, we're solving for problems when the limit goes to infinity. We did this on a graph. So if you remember from the very, very first section in the packet you did, remember we found the leftmost arrow and the rightmost arrow? So in this problem, what I'm going to do is do this algebraically. Okay. Here's a problem. I'm going to skip over this part. Okay. This one says find the limit as x goes to negative infinity. Okay. Here's the problem. If I plug in negative infinity, I get negative infinity to the third power, which is negative infinity. I get negative infinity squared, which is positive infinity, times a negative 2, which is negative infinity, plus 3. On the bottom, I have negative infinity squared, which is infinity, times a negative, which is negative infinity, plus 4 times infinity, which is infinity. Now, question is, what is negative infinity minus infinity plus 3 over negative infinity minus infinity? Like, this is not solvable, okay? Anytime you have an infinity problem, so again, just listen to me real quick and try to understand this. When you have an infinity problem, you only care about the highest exponent in both the numerator and denominator, because at very, very large numbers, the smallest terms don't exist anymore. So if I look at this numerator, if I'm trying to find the limit at infinity, this to the third power is going to be so much bigger than to the second power, or even this one, which is technically x to the 0 power. So for limits only that go to infinity, I will cross out the smallest terms in the numerator and in the denominator. So in this numerator, I don't care about 2x to the squared, and I don't care about plus 3 because they are nothing compared to x to the third at infinity. For the bottom, same thing. I have an x squared, I have a 4x. This does not matter at infinity. Okay, at infinity, x squared is going to be so large, we don't even care about 4x. Okay, now let me erase this real quick. Now, if those are canceled out, this kind of means the same thing as x to the third on the top and negative x squared on the bottom. Or it means the exact same thing at infinity. Then I'm just going to simplify this like I would normally do. I have x to the third over negative x squared, which means 2 x's on the bottom will cancel with 2 on top. So my answer is going to be 1 over negative 1. Or the answer is negative 1. Oh, wait. Let's start that over. I have 2 x's on the bottom that cancel with 2 on top, so it leaves me with an x over negative 1. So my answer is negative x. Okay, negative x. I'm not done yet because I have to find the limit. Remember, this problem was trying to find the limit as x goes to negative infinity. So when I plug in a negative infinity, negative infinity, the answer is going to be positive infinity. Okay? So again, in these type of problems, cancel out the smallest terms and then try plugging in the infinity again. Let's look at the next problem. Here I have an infinity problem. So again, I'm not going to try plugging in infinity because I'm going to get a giant mess. What I'll do is I'll cross out the smallest terms. What are the smallest terms in the numerator? Yeah, 2x squared and 3. And when I say smallest terms, I'm talking about smallest exponents. And again, 3 is similar to x to the 0. And the bottom is 4x. You'll notice that this is the exact same problem as we just did. So this simplifies, again, if you remember, into negative x. Okay. Why am I doing the same problem again? Because this problem just says positive infinity. Limit as goes to positive infinity. So that means for this particular problem, the answer is negative infinity. When I plug in infinity, I'm going to get a negative infinity. Okay. Let's try one that looks a little bit different. How about this problem right here? Okay. Now, still kind of the same process. I'm going to cross out the one with the smallest exponent with x. This one doesn't even have an x. I'm going to cross out 5. On the bottom, I'm going to cross out a minus 4. It doesn't even have an x. This simplifies into radical x squared over 3x. Okay. And again, I could do this because I'm trying to find a limit at infinity. In the numerator, the square root of x squared is just x. Now you see an x on the top and the bottom will cancel, and I end up getting 1/3. And you may be asking yourself, 1/3, like where do I plug in the infinity? If you get just a number, then your answer is the number. Okay. And the one, this one on the right is the exact same thing. You end up canceling. It's the exact same thing, 1/3. Again, since there's nowhere to plug in an x, this one is also 1/3. Let's do one last one for this section. Here's a problem that goes to infinity. Which one has the smallest x exponent? It's 3x. And this one, 2. This simplifies at infinity only 4x squared over negative 5x third. I have 2 x's on the top that will cancel with 2 x's on the bottom. So that will give me 4 over negative 5x. This is where I plug in my infinity now. Okay, take my infinity and plug it in to x. You'll notice if I plug in infinity into x, I'm going to get 4 over infinity times the negative 5 will be negative infinity. You may be saying, what is 4 over negative infinity? What is 4 over a very, very large number? Or anything that is divided by infinity, the answer is always 0. Think of it this way. If your denominator is very large, it makes your fraction very, 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 very tiny. So here's another helpful hint. Anything divided by infinity is equal to 0. So that's it for this standard. It's finding limits involving infinity, whether it's plugging in a number and getting infinity, or plugging in infinity and finding out what the limit is. Hopefully the infinity stuff is easy for you, because the process is a little bit less time consuming as the previous one. So hope you understand. Again, if you have any questions, you're going to put it down in the questions below, or you could ask those questions to me in class. So hope you have a great day, and I'll see you all later.